surface, but the delta is on the what? On the pink colored surface. Anyone, any questions so
Sir,
far?
what is delta?
Delta means the change in distance.
Oh, shear.
Okay.
Okay, this. Okay.
Okay. Because of the slip. You've been through materials, right? Structure and properties. It's a slip, basically, right? So my question is this. How can the shear in this direction induce a failure, right? Induce a failure in this direction that I'm circling now? Anyone? They are not on the same plane, am I right? Right? Yes.
Yeah.
Right? So how does this work? Remember what I told you, the criteria that we set up? What did we say? The shear in X plane intersecting Y direction is equal to what? So when you draw a shear down here, you have another direction of shear over here, and this is your shear intersecting Y plane in the X direction. That is why this delta in a different plane of orientation will induce a what? A failure, right? So this condition has. So if I were to draw this in 3D now, right? So if we were to draw this in 3D now, right? X, Y, and Z, right? We know that the shear force is acting down this way, right? And then the shear stress is in this direction, right? So the shear, this is the shear XY, and action equal to reaction or equilibrium shear YX. So that's why the delta in this direction is still valid. Okay, so this delta direction and this delta direction, they are in the same plane, right? Any questions so far? No? Okay, so now I will write for you the formula. In this next 2 weeks, 2 formulas. Okay, you only have 2 formulas, but these 2 formulas have rules that you have to understand to apply. If the rules you totally ignore them, okay, your analysis will be wrong. Okay, so there are 4 rules which we will derive. Okay, there are 4 rules. Okay, so let's start. Not yet. I'm not going to start on the rules yet. I'm going to start on the shear flow. Any one question? Are we okay? No? Okay. So the shear flow or another term is the horizontal shear per unit length. So the formula is equal to Q is equal to VI, VQ over I. So this is the shear flow. So this is the formula that I want you to know. And I want you to take this into consideration. V is going to be your V max. It's going to be a constant. I is a global second moment of area. And this will be also equal to a constant. The only thing that's going to be a variable is Q. Okay, so that is going to be the variables. So rule number 1 I'm going to put down here. Rule number 1 is that V and I are constant, okay, regardless on the point of analysis. Okay, so V and I are always constant. The I, the second moment of area, is the global. I'll explain what is global later on. Okay, where we have Q is the shear flow, and this is in Newton per meter, and V correspond to your shear force, right, which is in Newton, and Q is your first moment of area, okay, with respect to the centroid. And the units is in meters cube. Okay. Now let me elaborate more about the first moment of area. Okay. Anyone, any questions so far? Okay. So I've showed you what rule number 1 is already. V and I constant. Yes.
Is the I the polar moment of inertia?
No, it's second moment of area.
Okay.
Okay. So the next thing that we're going to look at, we are going to look at Q. Okay. So Q, first moment of area, is equal to A y bar. Okay. So this formula is also very important. Where A is the defined area, and it's in meters squared, and Y is going to be the distance distance of the centroid with respect to the defined area. So the units is in meters. If it is inches, then you go inches. Okay. And then I correspond to the second moment of area. Okay. And this will be, the units will be in meter 4. Okay. So that is the shear flow. And then if you look at the shearing stress, right? The shearing stress shear is equal to VQ over IT. So it's very similar to the shear flow. The only thing that's different is your what? Is your thickness, right? You only put in the thickness. So again, I like to emphasize that the V and the I, they're all constant. They will not change. The Q and the T, they're all your variables, depending on what you're going to analyze. So T correspond to the thickness of the section. Okay. So this is in meters. Okay. Right. So we are now going to look at, so far, are you all okay? I know now it's just a bunch of formulas, okay? Right? And I've introduced. Yes.
Yeah, I have a question. In terms of like the Q equals A, Y, what does the I correspond to in that equation?
So the I over here, okay, the I is a new term, okay, nothing to do with the Q. The I is over here.
Oh, okay.
Okay, got nothing to do with the first moment of area. Okay?
Okay. Thank you.
Okay. No, yeah, thank you for clarify that. So now
Eugene,
yes.
what's the difference between the first area of moment and the second area?
So that's what I'm going to show you now, okay? Right. So I've given all these images on Avenue to Learn. Okay, so if you go to the lecture notes, all these images are there. Right. So we are going to now, okay, what we are going to do now is we are going to look at the shearing stress in a thick wall section. Okay, now just now the question was good. Okay, the first moment of area Q is basically the area multiplied by the centroid distance. The second moment of area over here is basically the resistance to bending. Later on, or after your first term test, you will see more second moment of area, but I'm still going to teach you second moment of area over here. Okay, it's a resistance of bending in structure analysis, where first moment of area is basically the area multiplied by the perpendicular distance from the centroid. Okay, so now let's look at Q first. Okay, so we are going to look at the shearing stress in a thick section. So this diagram over here. So our transformation. Okay, so if we were to draw a transformation, I'm going to follow the transformation. There's a diagram. This is your y-axis, and this is your z-axis. So we're going to look at the shearing force. Okay, the shear force V is in the y direction. Okay, so we're going to have the shearing force. Okay, yeah, too thick. Right. So when the shearing force is in Vy direction, right, the area of interest is over here. So this is the area of interest. So let me introduce you to this diagram further. Okay, where y, right, where y, I'll introduce you to this diagram where y is the variable, or in other words, the slider. Okay, so the y, this y over here can go up and come down. Okay, y prime is the centroid of the